There are only 3 types of absolute value equations in total. If you can fully understand these 3 types, you won't have to worry about any absolute value problems. Let's look at the first and simplest type. For example, the absolute value of 3x minus 2 equals 8. How do you solve this? Everyone, if its absolute value equals 8, that means what's inside must either be positive 8 or negative 8, right? There are 2 cases. In the first case, 3x minus 2 equals positive 8. If that's the case, what do we get? 3x equals 10. So x equals 10 divided by 3, right? What's the second case? 3x minus 2 equals negative 8. So there are just these 2 cases. Either it equals 8 or it equals negative 8. What about negative 8? Let's calculate it. 3x equals what? If negative 2 moves over, it's negative 6, right? So x equals what? It equals negative 2, right? What L over B value? Isn't it negative 2? Remember, you must substitute these 2 answers back into the original equation to check. Try substituting negative 2 back in. Negative 2 times 3 is negative 6. Negative 6 minus 2 is negative 8. Now try substituting 10 thirds back in. 10 thirds times 3 is 10. 10 minus 2 is 8. Both answers work, so both are correct. But you must always check by substituting them back in. Second, here, the left side is an absolute value and the right side is an expression. Again, there are 2 cases. Everyone, there are 2 cases here as well. Either this expression equals itself or it equals its opposite, right? So there are 2 cases as well. Just calculate both cases and that's it. 3x minus 4 equals 2x minus 3, right? Work it out and see what x equals. What does x equal? Move it over and you get x. Move the negative 4 over and it becomes 1, right? Isn't it equal to 1? Okay, now for the second case, 3x minus 4 equals negative 2x minus 3, right? So these are the only 2 cases. Then when you move this over, 3x plus 2x becomes 5x, right? Move it to the left side. And when you move the negative 4 over, it becomes positive 4, positive 4. This is positive 3, so isn't it equal to 7? Isn't it 7? So this is positive 3 and positive 4. X equals 7/5. Let's try substituting it back in. You must check by substituting x equals 1 back in. 3 minus 4 is negative 1, no problem. This one's fine. Substitute 1 back in, no problem. Now for 7/5, substitute it back in. 7/5, 3/5, 7 times 3 is 21. So 21 over 5. 21 over 5 minus 4. That's 20 over 5. So isn't that 1/5? The left side is 1/5, right? What about the right side? Substitute 7/5 back in. That's 14 over 5. 14 over 5 minus 15 over 5. How did it become 2/5? When doing problems, you need to practice like this. So where did the mistake happen? Everyone made a mistake, right? 3 words. Minus 4 equals negative. Move this over. 5x minus 4. 7 is fine here, right? 5 times 7 is 35. 3 times 7 is 21. How could this be wrong? Everyone, substituting this back in is incorrect, so let's rule this out. So in this situation, everyone, how do we handle this third situation, the third case? This situation is the same as the previous one. There are absolute values on both sides, which means 3x minus 4 either equals 2x minus 3 or it equals negative 2x minus 3. Right? It's the same as this one. So for these 3 types of problems, you just need to work through both of these cases and then substitute your answers back in to check. Isn't that right, everyone?